Greetings! Welcome to our last video tutorial on data representation. This lesson deals with data compression. Let's see what's in store for us today. In this video lesson, we shall understand the purpose of and need for data compression, as well as discover how files are compressed using lossy and lossless compression methods. Data compression is defined as the process of reducing the size of a computer file. Processing power and storage space are very valuable on a computer. To get the best out of both, we can reduce the file size of text, image, and audio data in order to transfer it more quickly and so that it takes up less storage space. Through an algorithm or a set of rules for carrying out an operation, computers can determine ways to shorten long strings of data and later reassemble them in a recognizable form upon retrieval. The result is a file that uses fewer bits or units of information than the original file. Data storage and transmission are often important concerns for businesses, governments, and other organizations. Compressing data allows these organizations to maximize the data they can handle while minimizing the associated space and cost. This reduction of space and time can result in significant cost savings. For example, organizations that store large amounts of data, such as corporations and healthcare providers, can save on data storage expenses as compression allows them to store more files with less capacity. Also, since compressed files take less time to transmit across the internet with less risk of errors, such organizations have less need for investing in costly bandwidth upgrades. For certain other organizations, compression allows them to provide optimal service at the highest convenience. For instance, telecommunications providers handle enormous amounts of audio and video data. Compression allows them to provide service to a large number of customers with minimal compromise in auditory or visual quality. In addition, large files take a lot longer to download or upload, which leads to web pages, songs, and videos that take longer to load and play when using the internet. Compression addresses these issues. Compression methods are classified into lossy or lossless compression. Lossy compression allows degradation of a file to an acceptable amount, but a user cannot recover its complete original data. In contrary to lossy, lossless provides full data recovery. Lossy compression is used when it does not matter if some of the quality is lost. For example, for a photograph or a video, some quality can be lost, but the product will still fulfill its intended purpose. In lossy compression, the user's chosen compression software removes non-essential sections of data, such as the number of colors in an image. This results in a smaller file and a minimal reduction in quality. This might also mean removing audio elements in an uncompressed song that a person will not likely hear, or reducing the number of samples in a sound file. This can result in a small loss of quality of an image or sound file. Lossy data compression removes some actual data, but leaves enough remaining data for the compressed format to be still usable. However, it is not reversible. Lossy data compression is widely used in video and sound because the information lost is generally not detected by a viewer. For photographs and other still images, JPEG is a preferred file format that has only lossy compression. With JPEG compression, the creator can make a decision on how much loss to bring in and can strike a balance between file size and image quality. A classic example of lossy compression is the reduction of the resolution of an image. the lower resolution image is still recognizable as the same picture, and thus the data loss is a useful trade-off between image quality and file size. An important example of where picture quality reduction is desirable is where they are displayed on web pages. The time taken to download images is directly related to the size of the image file. If the purpose of the transfer is only to display on the screen, then there is no point in transmitting an image that has greater resolution than the display screen itself. In general, a 10 megapixel image will not look any different to a 1 megapixel image when displayed on a screen with a resolution of 1 million pixels. However, the 10 megapixel version of the file would take a lot longer to download and contribute much more to the level of traffic on the network. Lossless compression is used when no information can be lost. For example, when compressing the source code of a program. If you lost some of the source code, the program may not function. In lossless compression, the user's software locates similar or identical sections of data within it. Then, it replaces each instance of a certain replicated section within a unique identifier, enabling it to be restored later. This shrinks the file without losing information or file quality. Compressed files do not experience a consistent reduction in size. With lossless compression, every bit of data originally in the file remains after it is uncompressed, and all the information is restored. The algorithm reduces the file size in such a way that it retains the information needed to expand the file to its original size when decompressed. There are various algorithms for doing this, usually by looking for patterns in the data that are repeated. Zip files are an example of lossless compression. The lossless format is necessary for files that cannot function or is noticeably compromised without all the original data. Such files include software applications, documents, and certain media formats used by different people such as photographers, filmmakers, and musicians. Financial data or text in a document cannot be subjected to lossy data compression. It would be meaningless to just remove a few characters from each page of a document to reduce the file size, for example. In lossless compression, the information content is squeezed into a more efficient form of encoding, but with no loss of precision or accuracy. Lossless compression is used to keep up the similarity between the original data and decompressed data such that there are zero deviations. Similarly, in an image, there are adjacent pixels that do not differ from one another. To apply lossless compression to an image, it is wise to find groups of repeating data and record the data only once with the number of times it was repeated. Run length encoding is a lossless compression method that takes advantage of often repeated strings or runs of repeated data. For example, the picture contains brown pixels on a white background. In the first row, we have 3 white pixels followed by 2 brown pixels and 3 white pixels. The algorithm can report that there are 3W, 2B, 3W in the first row and then remove any redundant data. Similarly, the last row can be represented simply by writing 8B. Though the algorithm adds some data, it removes much more, reducing the overall size of the file. Run length encoding can also be used to compress images without losing information. Let's look at an example. A lossless run-length encoding algorithm is used to compress the images. This table shows some of the data for an image. Apply run-length encoding to the data and give the result. How do we go about it? We see that there are long runs of repeating data in the image. A repeating string can be encoded in two values. The first value representing the number of identical data items in the run, and the second value giving the code of the data item. In this case, any one of the given coded versions would be appropriate. See if you can encode on your own. Either of these two codes would do. Here comes a second question. In the event of very few repeated patterns, run length encoding would not lead to significant reduction in file size. Let's compare the two classes of data compression. Lossy compression permits reconstruction only of an approximation of the original data, though usually with improved compression rates. Lossless compression is a class of data compression that allows the original data to be perfectly reconstructed from the compressed data. Irreversible compression is another name for lossy compression, while lossless compression is also called reversible data compression. While lossy compression reduces the quality, lossless compression does not reduce the quality. Data reduction in lossy compression is higher than in lossless compression. In lossy compression, a file smaller than the original file is produced. In lossless compression, the resultant file is not as small as the lossy compression's resultant file. Lossy compression is commonly used to compress multimedia data such as audio, video, and image files. Lossless compression is used for text, data files, audio, and images. There are generally different types of data compression based on the type of data that we want to compress. Text data compression involves identifying patterns and redundancies in the text and encoding them using shorter codes or symbols. The effectiveness of a compression algorithm depends on the type of text and the required compression ratio. A lossless text compression method is a run-length encoding that, as mentioned before, replaces consecutive occurrences of the same character with a single occurrence and a count. Like text compression, image compression searches for patterns and redundancies in the file and creates shorter codes and symbols. For example, it might recognize a repeated color pattern and create a code with the color and its number of occurrences that are the same size as 1 unit of the original. JPEG is a lossy image format commonly used for website images. Audio files are computer files that we can listen to, but they do not often contain other types of data. The primary way to shrink audio files is by using lossy methods where background noise and white noise are both removed from the files. MP3s are audio files compressed using lossy compression. Since videos use both images and audio files, a combination of lossy methods are used to eliminate background noise and keep the most important parts of the video. MP4 is a lossy file compression format, but it still retains an acceptable quality of sound and video. Work out the following questions. Question number 1. Define the term compression. Question 2. Explain one difference between the two compression techniques. Identify which compression technique is most appropriate for the following. Let us go through the important points of today's lesson. The basic principle behind data compression is to develop a method for using fewer bits to represent the original information. By eliminating redundancies and non-essential information, compression ensures optimal utilization of resources without compromising data integrity. Data compression helps to send data over the network quickly, and it also reduces the required physical storage area. Lossy and lossless compression are two techniques that reduce data size to store and transmit efficiently. The difference between lossy and lossless compression is that lossy reduces file size by permanently removing some of the data, while lossless restores and rebuilds the image into its original form after decompression. Lossy compression reduces the quality of the original data, while the lossless compression does not. Opposite to lossless, lossy compression allows a recovery of only part of the original data. However, this generally enhances compression rates. The space savings of lossless compression are not as good as they are with lossy compression. Lossy compression is generally applied to multimedia files, while lossless compression is most suitable for data files and text. We have come to the end of this lesson. Hopefully, you have become more knowledgeable about data compression that plays a crucial role in our digital world. Thank you. Goodbye.